Okay, should we start? Yes, okay. Hi, ciao. I want to talk to you about server components, React server components. You see, I made some Star Wars references, but they're mostly clickbait, so don't worry, you will see. And I want to also tell you that I'm not using React server components in production. I'm a DevRel, so I basically don't do anything in production, but I study things and I try to explain technical concepts. That's my work, more or less. I'm a developer relations engineer at Fabric. I'm Edoardo Dusi. And I don't know, if you find interesting the way I talk, the way I speak, the way I explain things, you can follow me online. You can follow me on Spotify and YouTube. I have a podcast in Italian. So if you want. And today, I want to take you to a journey in discovering how and why we got to React Server Components, not how to use them. You will not go home this evening knowing how to use them. This is not a tutorial, this is not a getting started. Probably I'm not even good at using React Server Components, but I try to understand the whys and the hows, because I think that we need to make informed decisions when we architect an application. Because I think we are, as developers, we are not code producer. We are not paid to write code. Everything today can write code, okay? AI can write code. We are paid to answer, to create solutions, to architect applications. So we have to come up with solutions, not with code. Code is the way we answer to requirements, okay? So I'm interested in discovering why some people decided to implement a new paradigm. And here we are talking about a new paradigm. This is a big change in the React world, okay? We are now in React 19. And with React 19, there are many changes, but one of the most, the most tricky one to understand is this one, is server components. Because when I first started to discovering what they were doing with the server components, it was difficult for me to understand why they decided to implement this new paradigm. Because at first I thought, we already have server-side rendered components in React, but this is not this thing. This is another thing. So the journey today will be about knowing the history of web applications and trying to understand why we got here and how to make more informed decisions. And so we structured this talk in 3 parts. The episode 1 will be the PHP menace, of course. Episode 4, because we're not following numbers are not important, will be the next op, and then we will see PHP that strikes back. It's just clickbait, okay? When I prepare a talk, I usually start with a quote. And this quote, I found this quote in a blog post. You can find this blog post by Josh Como. And this is a blog post in which Josh Como tries to explain React Server Components. I find it very useful. You should check it out. And this was the sentence that made me click, that did the click for me, okay, in understanding what React Server Components are really about. And this word exclusively is the word that really matters, okay? You have to concentrate on this word, but we will get back to it later. So let's start with episode 1, a bit of a history. So if you were a kid in the 90s, maybe you are familiar with this page. This is a page on Topolino, which is the Mickey Mouse in Italy, okay, a magazine. And with Topolino, they gifted their readers internet, basically, a week of free internet, because at the time you had to pay for internet. You had to pay for your subscription, not only for the connection, you had to pay a monthly subscription, and you had to pay a lot to vendors like Video Online, Italia Online, and others. You had to pay like 250,000 lire, and you had to pay for the phone call, and you can go to ludicrous speeds like 28K baud with the expensive modem. But at the time, this was the internet, okay? And this was also the computer, more or less, at the time. And in the 90s, 1995, more or less, the internet arrived in Italy. And in that era, the average homepage of the internet was like this. So a static homepage generated on the server. This was GeoCities, so more or less one of the most famous pages on the internet. And I think it was more or less more similar to this one. But you see many dynamic elements, many animations, but the page is static. The page is generated somewhere and served to the clients statically. Of course, the generation of the page was dynamic in the way that the page gathers information based on the request, but then the page is static and served to the client. So this was the internet. And at the time, we wanted scripts to gather information, collect information, connect to databases and other machines to generate this page and serve it to the client. So enter Rasmus Lerdorf, the creator of PHP, sorry. PHP, the original name was Personal Homepage. This is a snippet from PHP version 2 called PHP FI. I don't know how many of you knows what FI meant, but it's Forms Interpreter. And you see that it's a bit different than the PHP that we have today, but in the end, the logic is the same. Render something on the server, connect to a database, connect to a machine, connect to the POSIX API, gather data, informations, render a page, serve it back to the client. Then in 1998, we have more or less the 1% of the web made by PHP pages, because we can check the headers. And in 1998, there was a complete rewrite of the language. We have the new name, PHP Hypertext Preprocessor, the actual name. In 2000, we have a completely new, well, not a completely new, but a new version of PHP, the 4.0. We had a completely new engine, the Zen engine. And in 2004, let's say the modern PHP, PHP 5, with an object model, new features, and Zen engine 2.0. So this is how PHP works. From the client, you make this request to the server. If the request is targeted to a PHP script, the server passes this script to a PHP interpreter via a module on the web server or a CGI or whatever. But in the end, the PHP interpreter reads and executes the script. It can connect to a DBMS, to POSIX API, or to the external world with other calls, HTTP calls, for example. Then it generates an HTML file, well, an HTML string, for example, and then the server serves the string to the client, back to the client. So this is how PHP works. And this is a simple PHP component, okay? With the modern syntax, you have at the top a connection to MySQL. Well, lots of code is, but this is the core, okay, the important code. You have the connection to the MySQL database, you fetch data, and then a template with which you render the content of your page. So at the end, executing this script, you have a valid markup document, a valid HTML. So this executes once. This never re-renders because it's static, okay? Well, it's not static, but it gets rendered dynamically for each request and never re-renders. Re-renders once. And when this rendered page is served to the client, it never changes. So keep in mind this code structure because we will get back to it later. So this was just to throw in some Star Wars reference. So PHP all over the web and JavaScript rebels that wanted to fight the empire because JavaScript was, rebels wanted more dynamicity. They wanted to do more stuff on the client, less on the server. They wanted more, I don't know, they wanted more fancy stuff on the client. And so we have a next hope in episode 4. Because the problem under the PHP empire was that when you make a request to the server, you have to wait for the request to get processed and for the content to be rendered. And while you're waiting for this rendering, you basically see a blank page. You see nothing until the content is fully rendered, okay? So let's render the page on the client. And then we have the revolution of the XML HTTP request, with which we have the first request to the server. We get basically a shell of the page, very, very poor, very simple. So we can render, we can serve something, we can show something to the user. But then via the JS engine on the browser, we render more things. We make subsequent calls to the server, and the server still talks to a backend with its DBMS, with its POSIX API, and pieces of content are rendered and served back to the client. So the client renders dynamically the page while the content arrives, and in the meantime, the user sees loading content, loading pieces, and the experience for the user is way better because for the user, they see that something's happening, okay, under the hood. And then, of course, vanilla JS is complicated. So we have the framework revolution. And the frameworks was there ones at the time. So we had like the first version of Angular, we have Ember, we have Backbone, jQuery. Ways to manage our JavaScript, because JavaScript gets complicated. We have to make calls, tons of codes. We have to render pages, we have to render content, we have to stream, we have to do things. So to manage this code, we introduced frameworks. And PHP popularity began to decline. So every chart on the web with stuff. And then 2013, we have Facebook. So Facebook, we know that Facebook built React. But why Facebook built React? They wanted, well, Facebook had a massive platform, okay? They wanted reusable components. They didn't want to rely on templates. They wanted a declarative interface because it was easier for the designers and for the developers. They wanted the J6 syntax. They wanted more efficiency. They wanted to focus on the user interface. And they also wanted an open source ecosystem. Of course, they also wanted to be mobile first. So they built a framework that was also ready for the mobile. So the next year, they presented React Native. So you may think they created React, so they are with the rebels. They are with the JavaScript revolution, right? But let's have a closer look at Facebook. Because Facebook relied on PHP heavily. All the backend in Facebook was, and I think still is, in PHP. PHP was the primary programming language for front-end and backend. And the problem they had was that they grew a lot, and the PHP interpreters struggled. So this led to the development of HHVM, the hip-hop virtual machine. So with HHVM, they basically transcribed the PHP. They built a compiler, a just-in-time compiler, and so the performance improved. And then Facebook developed Hack. Hack was, because I think it still is, but mostly is a deprecated language, but it's a language built on top of PHP. So it's a superset of PHP. And Hack was the way Facebook developed their backend and their frontend in PHP. And HHVM was the runtime for Hack. And Facebook created this extension for Hack. You can still find it online on GitHub. It's an archived project. It's XHP. With XHP, you can write XML fragments in PHP files, well, in Hack files, but Hack files are basically PHP files. So I repeat, you can write markup, like XML code, in PHP code. And soon after, they developed JSX. Okay? So it's clear. JSX is basically XHP for JavaScript. This is code from Hack with XHP extension. You see markup inside of PHP. This is basically JSX, okay? It's translated. JSX is HTML in JavaScript. This is HTML in PHP. And I had to make this whole talk just to show this image because I love it. So face it, React is an illegitimate child of PHP. We have still PHP on the server. The rebels, they wanted to dethrone PHP. Okay. So React won the frameworks war. React was and still is the most used framework on the client side. But they want also to take over the backend. So we have issues with client-side rendering, so let's render on the server. And this got us to a new paradigm, the isomorphic JavaScript, which is server-side rendering, okay? This is a famous blog post by Airbnb, 2013. And with server-side rendering, we have this picture. The thing is, we make the first call to the server. The server renders a shell, very basic. The shell is passed to the client. And then with a process called hydration, the client gets more content from the server subsequently. So the first contentful paint is very, very fast because it's tiny, it's little content, it's tiny. But the largest contentful paint, that's the slow part. And it's in part rendered on the server and in part on the client. Of course, the user wants to see the largest contentful paint because the first contentful paint can be the header, some links, but the user visits our page to see content. So the important metric here is the largest contentful paint. We have to optimize for this. And server-side rendering has a bit of issues. But it was a good paradigm, and it still is with Next, for example. So you may think that the rebels won, but we have problems with server-side rendering, and this got us to the last part. We require hydration. So we need additional round trips to the server, and the user can't interact to the page if we don't have the first contentful paint. The user can only click on links, but we need the interaction with the proper content of the page. And then we have issues with re-rendering, because if you see the pictures before, you see that when we hydrate the page, we are basically re-rendered. And also on the first pass, we are rendering components on the server, and when the app is served to the client, we are re-rendering the same components. So this can lead us to issues. Then we have incompatibilities between client and server JavaScript libraries. We cannot use web APIs on the server, Node APIs on the client. We need to make checks, okay? And we have a larger bundle, because when we build the app, we have all the logic, the server logic and the client logic in a bundle that gets sent to the client, and the bundle can be big. Of course, we have more complexity, and we have a difficult SEO support. Without talking about state management with SSR. State management is very difficult. We have to really understand how things are going between the rendering on the server and the re-render on the client. And performance can be slow with this process. So yes, server-side rendering is not cool. Let's render at build time. And we got to the next step, static generators. So this article is pretty famous about among my colleagues. Static site generator was the next big thing in 2015. How static site generation works. We have a first request to the server, and if the server finds a rendered static version of the page on a cache, for example, on a CDN, it uses this version of the page and serves it back to the client. This is very fast. But of course, this call is anonymous. if the user wants to perform actions as an authenticated user, we have to go through client-side rendering or server-side rendering. Why? How can we build a static version of the page? Of course, we have the build on the server, we have still our node backend, we run the build process, we have our static pages, and we put them on a CDN. And this process should run every time we update the content. But when we have them, they are very fast for the user. So this is a pretty strong paradigm. But of course, when we want to be dynamic, we have to make trade-offs. So static rendering is cool, but we have trade-offs. And by the way, this was, when I searched on Google, happy old man and crying old man, same image, so I had to. Okay, so the good things with static rendering are that one. We have fast load times. It's easy to scale. We have a reduced attack surface because we don't need to expose our server, okay, on the internet. Pages are always online as soon as our CDN is online. Hosting our static pages is cheaper. We have SEO improved. We can cache effectively. But the flexibility that we have, it's less. And also the interactivity that the user has. We can have long build times. If we have a massive site, the build time can be slow, really slow. Imagine you go through a continuous integration and continuous deployment paradigm. Build times can affect your workflow. And content can become outdated. You have to build every time you update your content. You have cost that increases every time you build for frequent builds. And of course, you have SEO challenges and stale content if you don't invalidate your cache. Okay, so a bit of problems, but we want all the benefits of server-side rendering without the pains of server-side rendering. So if we could have something like dynamically rendering at first connection, executing some code only on the server, sending the HTML back to the client, and from that point, some JavaScript that take over. Enter Amazon. No. Server components at last is an answer to this request. So this is how server components work. We have a request to the server executes the rendering, at least the first one. This is, by the way, this is one way to use server components because we can also build them statically, but let's concentrate on the dynamic part. At every request, the server executes the page, renders the components, and serves the HTML, the components, with some serialized DOM back to the client. And from this point, the client goes with client-side rendering. So the heaviest part of rendering content is still on the server. We can also run this at build time and cache the content, we will see. But this is how it works. Content is rendered on the server only, and then the client takes over when the content is already rendered without having to interact again and to hydrate components because it just have the components it needs. This is a simple RSC component. Here you see that we are connecting to a database. We are fetching things, products, and we are using a template to print the product that we fetched. This gets executed once for every request. It never re-renders. It renders once, top-down. And the rendered value is sent to the client and never changes. And if you remember what we saw with PHP, basically it's the same thing. Well, let's keep this one because I want to go deeply. Okay. So let's concentrate on the exclusively word, as I said. when you render on the server with this pattern, what you got on the browser is just the rendered version. You don't see the source, you don't see the original component, you just see rendered HTML. So this means code is rendered exclusively on the server, not back on the client. The execution, if you remember our example, the execution is top-down. And that's why we don't have hooks, we don't have effects, we don't have state, because they are pattern designed for components that we render that are based on effects, events. But here we have a classic top-down approach. And also, well, you see that this component is async, but I will explain it later. As I said, we can run this at build time because, of course, we run it once. If our content doesn't change, we can take this and place it on the CDN. We can run it for every request dynamically. And one of the greatest thing of this pattern is that every dependency that we have when we run this render part on the server dynamically don't need to be included in the bundle. Because the source code and everything that the server uses to render our components doesn't need to be included in the bundle. So for example, if you need a big library, like the biggest you can think of, like Moment.js, if we want to use Moment.js just to format a date, we can include the dependency on the server, and the bundler is smart enough to know that they don't need to include Moment in the final bundle. So the final bundle is way smaller, okay, without including all that dependencies, because we don't need Moment on the client. Now, client components still exist. The thing is, every component by default is a server component with this paradigm. By default, if you want client components, you can have them. You have to use the directive useClient. So you see here, useClient is just a string that you place on top of your component, and the bundler knows that this component is a client component, just like useStrict when you use useStrict, okay? So in this example, we have a client component and a server component. The server component is an async function nodes. We include a client component expandable. So on the server, we render all the page, but when we send the component to the client has the rendered part, the rendered server part, and the expandable component, because the expandable is a client component. So the client can effectively run and render the expandable component. And sorry if this example is the same, but we cannot include the server components in client components, because if we render client components on the client, of course, we cannot render server components on the client. Server components run exclusively on the server. So you want to architect your application differently now. You have to think of boundaries between your client components and your server components. You cannot mix the two. You cannot include. So in this example, for example, you cannot include a server component like nodes into expandable as a child. And by the way, if you do so, if you take nodes and include nodes as a child of expandable, nodes becomes a client component, okay? And as you already saw, server components can be async. So you have async components, you can wait for things, and they cannot have state. Of course, they don't need also to have state. They cannot re-render, so they cannot use state. It's meaningless in this context. So benefits and downsides. Performance is the first benefit, because we have smaller bundles, and the first rendering is way faster because it's run on a server. We have security because we have server-side only code. We can connect to a database, we can perform calls with API keys. And we are sure that the code will never get sent to the client. And we have less hydration and less re-rendering and a smooth integration with React with features like suspense and streaming. You remember that server components are async, so we can perform a wait operation in a component. We can use suspense in components, in server components, and the loading of some operations can be passed to the client that renders, that waits with the suspense. It's integrated seamlessly. And we also have streaming SSR. So we can have a big page, big chunks of HTML served chunk by chunk via streaming to the browser. So also performance is great for the user. We don't need to pass the complete HTML. We can also stream it. But we have a new paradigm to master. We have to learn new things. We have incompatibility with many React hooks. You see, we cannot use useState, useEffect. And we cannot use many libraries that we have for React if they use hooks that we cannot use anymore. And as I said, we have client boundaries. We cannot include server components as child, so we cannot use a client component as root of our application. If we do so, everything becomes a client component. So we need to architect effectively our app. There's little documentation yet. If you go to the React Dev doc, you have a page about server components, but it's a little page. And now it is only supported in Next.js 13.4 with app routing, don't remember the name, app routing, the new routing, okay. And it's the only framework that supports server components right now. You can use server components with React 19, but you have also to handle the routes, the bundling, the serves. So you don't want to do that with React. You want to do that with a framework, okay? And the only framework you can use right now is Next. So now, in conclusion, the force that once powered the PHP empire is helping a new generation of React rebels, and we can build dynamic, efficient, and scalable web application. And that is the server admin. And this is, by the way, a real thing, competition. Throwing your server the fastest possible. It's true. I think it's in Japan or something like that. So thank you, and may the source be with you.